Hi, I'm Ian. I'm going to teach you today about X-ray production. So this is an X-ray circuit, and there's two sides to the X-ray circuit, the low voltage or primary circuit, and then the high voltage or secondary circuit. Most buildings operate on the exterior at 220 volts, and then in the interior it's going to be 110 volts at 60 hertz. For this example, we're going to be X-raying a patient at 120 kVp, 25 milliamperage, and 3 seconds. So what happens is you're going to grab your patient, but before you do that, you're going to plug in the machine. And what this is doing is doing the warm-up procedure. And basically what the warm-up procedure is it's getting the machine from room temperature to operating temperature. And what happens during this is these three currents are going to be racing over simultaneously to the filament and the X-ray tube's anode to warm it up to operating temperature. This makes it so that there's no cracking or breaking of any of the components inside of the machine. First, we're going to be discussing the filament current. And what this is it runs from the main switch down over to the variable resistor or MA selector. And the MA selector is basically this little dial, and it's going to be selecting, for our example, 25 milliamperage. And it goes to the notches based on the settings that you put in. So let's say we put more, it would go to the correct setting that we put in. The filament ammeter is going to read that as the correct setting if it is the correct setting, if it goes to the correct setting. After that, it's going to go up through these coils, over this way, into the auto transformer or kVp selector. And the way that it does this is through induction. There's going to be several places inside of the X-ray tube and X-ray circuit that has induction. And basically what induction is it's electricity jumping a gap by the use of magnetic fields. So right here and over here, the wiring is not connected. And the reason for that is because if they were to be connected, it could confuse the machine with the kVp or MA selector. So the induction makes it so that everything can flow properly and fluidly through each of them without touching. And so it jumps the gap, which is induction. So for this side, there's a step-down transformer. And the reason why it's called that is because it's more coils on the low voltage side and then less coils on the high voltage side. And so it also drops down, it drops it down. So over here it's 110 volts, and then over here it's 5 to 15 volts, 3 to 5 amps. The next part I'm going to be discussing is these two currents. And so this one is going to do the same thing. It's going to go through, flow all the way up these coils and then through the timer. The timer is going to be, it's going to be 3 seconds, just like so. And it's going to be 3 seconds, go through the exposure switch. And the exposure switch is basically a drawbridge. And so it's usually going to be raised up until everything is set in place. And it's going to go down, allow the current to flow in for those 3 seconds. And it's going to go over to the kilovolt meter, measure that it's the correct kilovoltage, which is 120, and then flow into the auto transformer. And the auto transformer is going to do the same thing as the variable resistor. It's going to be selecting based on our settings that we put into the machine, which is 120 for this example. Next, what's going to be happening is, since these coils are powered up just like this one down here was previously, it's going to go and through induction go over to this side, which is the step-up transformer. And the reason why it's called that is because there's more turns of coils inside this side than there is on the low voltage side. And then also it's supposed to be at 100, it's supposed to be at 10,000 volts. So for example, right now it's 7,000 volts. So since it's not the correct amount, the current is going to continue to flow on the low voltage side until it reaches that 10,000 volts, because there's not enough voltage to take an X-ray. If it's too much, for example, 11,000 volts, it will transfer over, but it's too much power and we don't want to damage the machine. So it automatically knows to go to this little piece, which is the ground, and it's going to store that away until it is the correct amount, which is the 10,000 volts. Exactly, it has to be 10,000 volts. And then now we have reached the 10,000 volts. Same thing, it's going to flow over to this side. It's going to start up here, go through these diodes, through the X-ray tube, and then just continue to follow the path. And then as it does this, the electricity is going to be stored in the capacitor and then go over to the falling load generator and then through the rectifiers. The capacitor is just the storage place for it. And then there's another current which is going to go the opposite direction, this way, through the diodes, through the X-ray tube, and then back over this way. So notice how these sides are parallel this way, and then these sides are parallel this way. They're not going to run on the same diode plane pretty much. And then just like here, it's going to be parallel this way and then parallel this way. And it's going to go through those rectifiers 4 times. And so while it's going to go from a alternating current down to a pulsating direct current. And the reason why this happens is because there can't be so much energy and electricity going into the X-ray tube because it could damage it. And then another thing is it's going to be dropped into pieces, if you could say, like 10,000, like droplets, 10,000, 10,000, 10,000, each time that you need it. It's not continuously flowing, because if it was, it could damage the machine. So there's multiple ways to protect the machine, and this is it. 4 times through the rectifiers. And then this is the X-ray tube. The X-ray tube, the majority of the components are encased inside of a Pyrex glass or metal, and the only part that is not going to be inside the envelope, that's what the Pyrex glass and metal is. It's all the envelope. The only part that isn't going to be inside there is going to be the stator and the stator electromagnets, and that's this part right here. Inside so this is the cathode, which is the negative side, and then the anode, which is the positive side. This is the filament. The filament is going to be made out of a thoriated tungsten. And the reason why it's made out of tungsten is because it has such a high melting point and high vaporization point. Since there's so much heat going on to that, we can't allow it to get so hot, because if it were to get so hot, it would melt. So basically it's always going to be having backups. So just like the electricity had the pulsating direct current, this is another backup. It's made of such high melting, high heat taking material, so that way the machine doesn't get damaged once again. And then the tungsten anode is also made out of tungsten for the same reasons. In here is a focusing cup, and the focusing cup is lined with electrons, and those electrons are going to, it's the law of repulsion attraction. Like signs repel and unlike signs attract. So these like signs, which are all the electrons, are going to be repelling all the rest of the electrons that are inside here, inside the thermionic cloud. And then so it's going to shoot those out because they're repelling. It's going to shoot those out, and it's also assisted with neon gas. So consistently there's like backups just to make sure that the machine is doing what it's supposed to do properly. But there's some cases where it's not able to do that. So for example, there may be stray electrons that go throughout the envelope, and the neon gas won't be able to push it down. So those will go up here anywhere in between the envelope, and that's called tube arcing. And the tube arcing, it'll gradually get more and more electrons, and then those electrons are going to repel each other, and they may flow down and block the electron beam that is shooting across. And the electron beam is aimed at this part, the tungsten anode, and that's usually at a 12 degree. And the reason why is so that it could shoot those down into this window and allow the X-ray beam to happen. That is pretty much it. I hope you got all the information you needed, and like, comment, subscribe.